Today we're pulling back the curtain on two simple ideas that secretly run pretty much our entire digital lives: stacks and queues. Now, I know that might sound a little technical, but it's really just the hidden logic behind every single click you make.
I mean, think about it for a second. You're typing, you delete something, maybe you reformat a paragraph, and then you hit Control-Z and poof, your computer just reverses time, perfectly retracing every single step. How in the world does it remember all of that in the exact reverse order? Well, it's not magic. It's actually a beautifully simple structure in the code.
And you know, the most powerful ideas in computer science almost always come from things we do every day without even thinking about it. So to really get what's happening in the code, we just need to look at two super familiar scenes from real life.
A stack of plates and a line for tickets. Believe it or not, these two images right here hold the key to understanding how stacks and queues organize our entire digital world. So let's start with the plates.
Okay, first up, the stack. Its core principle is so simple you can sum it up in just 4 words. Last in, first out. LIFO means exactly what it says. Last in, first out. So the last thing you put on the pile is always the first one you take off. All the action, both putting stuff in and taking stuff out, happens at one single spot, called the top. And that stack of plates is the perfect way to picture it. You'd never try to grab a plate from the bottom, right? The whole thing would be a disaster. Nope, you add a plate to the top and you take a plate from the top. It's simple, it's intuitive, and that is exactly how a stack works inside your computer. And of course, programmers have a couple of simple verbs for this. When you add an item to the top, that's a push. And when you remove that top item, that's a pop. Let's see what that actually looks like. So here's how the system keeps track. Let's say we start with an empty stack. We push the number 40. See how that little marker, the top of the stack, or TOS, moves up to point to our new item? It's kind of like a bookmark that always shows us where the top is. Every time we push something new, that bookmark just moves right up with it. Now, getting data out is just the reverse. When we pop, we remove the very last thing we added. In this case, that number 10. And the towels bookmark moves back down. And here is the really crucial part. We can't get to the 32 or the 25 that are buried underneath. The only thing we can access is what's on top. Last in, first out. So where do you actually see this in action? Oh, everywhere. Remember that undo function we talked about? Every single action you take, typing a word, formatting, deleting, gets pushed onto a stack of commands. When you hit undo, the computer just pops the last command off the stack and reverses it. Your browser's back button? Same exact idea. Each web page you visit is just another item pushed onto the stack. All right, now for our second big idea, the queue. If the stack was like a pile of plates, the queue is much more like a line of people. And it follows a totally different, but just as intuitive rule. A queue is all about fairness. It runs on the FIFO principle, first in, first out. Unlike a stack with its one single top, a queue is open at both ends. You add to one end and you remove from the other, just like a line at the movie theater. And just like the stack, queues have their own special verbs. Adding a new item to the back of the line is to enqueue, and removing an item from the very front of the line is to dequeue. Let's watch this play out. An empty queue has 2 markers, front and rear. When we enqueue our first item, say the number 30, both markers point right to it, because, well, it's the beginning and the end of the line. But as we start to enqueue more items, you'll see the rear marker moves down the line, always pointing to the newest arrival. Now, when it's time to process something, we always dequeue from the front. The first one in is the first one out. The front marker just moves to the next person in line, making sure everyone gets served in the exact order they arrived. It's a really orderly and fair system. And you use queues constantly. When you send a bunch of documents to a printer, they don't just print randomly, right? They go into a print queue, and they get processed in the order you sent them, FIFO. Same thing for streaming video. All those little data packets get queued up to make sure you get smooth playback without any glitches. So now we've got these two really powerful tools with two very different rules. Let's put them side by side and break down the key differences. Okay, this table really lays it all out. The absolute core difference is the principle. LIFO for stacks means you're always dealing with the most recent thing, which is why it only needs one pointer, the top. But FIFO for queues means you're managing a whole sequence, so you gotta have 2 pointers to track the beginning and the end. And that fundamental difference changes the actions you can take, push and pop at one end, or enqueue and dequeue at 2 different ends. Ultimately, which one you choose just comes down to your purpose.
If you need to retrace your steps or reverse a sequence of events, a stack is the perfect tool for the job. But if you need to handle tasks fairly and in the order they showed up, a queue is really the only way to go. And this all leads to a much bigger idea. These aren't just some obscure programming tools. They're actually fundamental ways of thinking about and solving problems. This quote really gets to the heart of it. Great problem solving isn't just about hammering out code. It's about finding the right structure. Before you do anything, you have to ask yourself, what is the actual shape of this problem? Does it need to be handled in reverse order, like a stack? Or does it need to be a fair, orderly sequence, like a queue? Choosing the right pattern, that's half the battle right there.
Because in the end, that's really all these are. They're patterns. They are incredibly simple rules for organizing information or organizing tasks. Think about a stack of paperwork on your desk that you're going to deal with later, or a queue of emails that you need to answer in the order you got them. So the next time you hit undo or watch a video buffer, you'll see that hidden pattern that's making it all work. And that's our final thought for today. Once you know what to look for, you'll start seeing these simple, yet powerful rules everywhere. What stack or queue is organizing your world right now?